Today's video is going to be about domain and range. And we're just going to hop straight into the most important concept to get from this video, the definitions. Domain refers to the input, meaning if we're talking about functions, that's generally our x variable that we tend to use as our input. Range represents our output, which we generally refer to as y, or sometimes we also refer to as f of x, right? That's usually how we will refer when we're dealing with our functions. We usually have x be our input and y be our output, but obviously x and y are just arbitrary variables, so it's better to use input and output as the definition because really y and x, it could be any variable. So that really is the main concept for the lesson today, that domain is the input and range is the output. Now we're going to look at multiple different types of examples of how information can be given to you that you would need to determine the domain and range from, so I would still recommend scanning through the rest of this video at least, if not watching the examples, but truly this is the main concept right here. What you see on the screen are two different ways that information could be given to you about a function. We'll start with the one on the left. The one on the left is called a mapping diagram. Basically, the idea is you can follow the arrows from each input to their corresponding output. So like what this is telling us is, whatever the theoretical function is, if we plug -3 in as an input, we apparently get +1 as an output. If we plug +2 in as an input, we get +3 as an output. If we plug in +3, we get -2 out. That's the idea of a mapping diagram. So, if we were to be asked to find the domain, to state the domain and the range for this, we can only use the information we have in front of us. We don't know the entire function. We can't show that there are more inputs and outputs. We can only work with what we have. So we know the domain is our input, which means we are definitely looking at these three numbers in the input column. But that's all we can use. So what we have to do is we have to just show that it's listing out these three inputs, and the symbols we use for that are called set builder notation. They are the squiggly type lines. It's not a very gray one. Something like that. Set builder notation brackets. We use those when we are simply creating a list. And so our list for our domain would be -3, +2, and +3. And then we just close it off with another set builder bracket. Same idea with the range. We know range represents our outputs. Our outputs are clearly labeled as well. It's the 3 in the output column. So we would again be creating a list, so we'll use the set builder notation brackets. And it'd be -2, 1, and 3. That's it. That would be the domain and range for that example. Now if we look at the right half of the screen, this other example, this is an XY table. Not really that different from a mapping diagram if we recognize that X is our input and Y is our output. So it's still the whole left column here representing our input. And we still can only use the information we have in front of us. We don't have the entire function or anything like that. So while our list is going to be a little longer, it is still simply going to be a list. So once again, we would use set builder notation, and we would just list out -1, 0, 2, 4, and 9 for our domain. Our range then, being the outputs, would be the y's. You plug in x and then get a y back out, right? So our range is again just a list. So we again use the set builder brackets, and it's just 2, 3, and 6. Notice I am not writing 3 multiple times. Yes, it shows up 3 times there, but we're simply making a list of the numbers included in the range, the output. So it's just 2, 3, and 6. Let's take a look at these two graphs and try and find the domain and range for these. Now the catch is this is going to be a little different from the examples we did previously, because with the last examples we were able to just make lists, some discrete lists of our input and output. We're not going to be able to do that here. Reason is, if you look at these lines, you'll notice they're not just integers that we'll be including. Like, it's not just -1 or 0 or +1 that's part of our domain. It's also all the decimals in between them as well. And we can just keep writing decimals forever, right? I mean, you can put 1.1, but then you can put 1.11 and then 0.1111, and so on and so forth. So we can't just make a list. What we're going to do instead is use interval notation. You should have already watched the video on interval notation before looking at this lesson, but if you are not sure what interval notation is, I would recommend stopping here and going back and watching that video to refresh first before you continue watching this. Remember, the idea with interval notation is we want to list our least number, comma, our greatest number. If we want to do that for our domain, we remember that our domain is the input, or the x's, and we know the x-axis is our side-to-side axis, our horizontal one. So we are looking left to right, left being the least numbers because those are our negative numbers, that's our negative direction, right being our greatest because that's in the positive direction. So if I'm looking at this graph on the left, the question I should be asking myself is, how far left does this graph go, and how far right does this graph go? Well, we have an arrow here, meaning it was meant to imply that we assume the graph continues in that direction forever. That arrow is pointing both left and up, and so all I care about is the left part right now. Since it is pointing left, we assume it's going to continue going left forever. The math term for forever would be infinity, and in this case, with it going in the negative direction, that would be negative infinity over here. So that's where we're going to start our domain as. Remember from our lesson about interval notation, it would have a parentheses because infinities always have parentheses. Next question would be how far right this graph goes. And again, we have this arrow showing that it goes to the right forever. Or in other words, positive infinity. Again with the parentheses. Then we'd want to talk about the range. Range we know is the y values, or the output. So we would want to ask ourselves, how low does this graph go, and how high does this graph go? Because if range is the y's, and we know that this is the y-axis, that's the up and down movement, the up and down axis, the vertical axis. We want it to be from least to greatest, so we have to go lowest first, highest second. Our lowest point would be right down here at our vertex. We want to use the y-coordinate because it's the range, so that would be -2. Remember from interval notation, a closed dot would be a bracket. Now we need to ask ourselves, how high does this graph go? Well, we can see from both these arrows really on the left side and the right side that they are pointing up. So we have to assume this graph would continue going up forever, or in other words, positive infinity, which would need a parentheses because of what we've discussed already. Looking at this graph on the right, now with this one, you will notice there are no arrows. So we aren't meant to imply that this graph goes on forever. We actually get to work with what we can see here. So if we start with the domain, again, domain is the x's, or the inputs. The x-axis is side to side. So we're asking ourselves for the domain, how far left does the graph go, and how far to the right does the graph go? To my eye, the leftmost point on this graph would be right here. That is how far left the graph goes. Since it's domain, it's the x's, we want to use the x-coordinate for that point, so we will start our domain at -6. That's the x-coordinate for that point. It's a closed dot, so we would use a bracket. Then I want to ask myself, or we want to ask ourselves, how far to the right does this graph go? This looks like the rightmost point to me. Again, using the x-coordinate, that would be 4, +4. We would again use a bracket because that is a closed dot. Now we move on to the range. The range being the y values, the y-axis being up and down means we want to know how low, how far down does this graph go, how high, how far up does this graph go. The lowest point would be right down here. We want to make sure, since it's the range, we are using the y-coordinates. Our range does not start at 0, it starts at -3, closed dot with a bracket. We are using the y values. The highest point also happens to be the leftmost point. This is over at -6, +2. But this time again, we will not be using -6. We want to use the y coordinate, which would be +2. Close dot, so a bracket. That would be domain and range using interval notation.